So we are learning about factoring, and today we're going to factor using the greatest common factor, otherwise known as GCF. So to start off with, let's go back and review what a greatest common factor is. So starting with factoring, if I were asked to just factor a simple number like 30, there's tons of different factors that can go into 30. I can use 5 times 6 or 15 times 2 or 10 times 3. I'm going to start off using 15 times 2, and it doesn't really matter which two factors I start off with because we're going to break this down even further into something called its prime factorization. Do you remember that? It has been a while. When I'm talking prime factorization, I need to notice that this 15 can be broken down even further into more factors. So 15, for instance, breaks down into 3 times 5. 2 is a prime number, so I'm just going to leave it as 2. So the prime factorization of 30 breaks down into 2 times 3 times 5. No matter what two numbers I start with, I'm always going to end up with a 2, a 3, and a 5 to give me 30. So prime factorization of 30 was 2 times 3 times 5. If I broke down 40 in the same way into its prime factorization, I would get 2 times 2 times 2 times 5. When I talk about greatest common factor, I'm looking at what these two numbers have in common in their prime factorization. Both of them have a 2 and both of them have a 5, and that's the only thing that they have in common. When I multiply those two numbers together, 2 times 5 is 10. That's the greatest common factor for 30 and 40. In other words, 10 is the largest number that can be evenly divided into both 30 and 40. So let's take a look at terms where there's variables involved, like 5x squared y cubed and 15x to the fourth y squared. I want to factor both of those terms. So if I factor both, and 5 is already a prime number, so I'm going to leave it as 5. X squared is x times x, and y to the third is y times y times y. 15 can be broken down into 3 times 5. Those are both prime numbers. X to the fourth is x times x times x times x, and y squared is y times y. So I broke both of those down into their prime factorization. Now I can find their greatest common factor. Again, I'm going to look at what both of these have in common. Both of them have a 5. Both of them have at least 2 x's in common and 2 y's in common. If I multiply those together, a 5, 2 x's, and 2 y's, I get 5x squared y squared. I don't want to multiply 5 times 5 and have 4 x's and 4 y's because none of these have 4 x's and 4 y's, right? I just want to take what they have in common and multiply them together. So sometimes we're asked to factor a polynomial by using a greatest common factor, which is our main goal today. That means to take out the greatest common factor and write down what's left over in a set of parentheses, and this is also described as reverse distribution. So let's look at our first example. This expression has 3 terms. We're going to break down each term individually into its prime factorization. Eventually you'll get to the point where you don't have to do this process anymore. You'll just be able to see it off the top of your head. But for now, while we're learning it, we're going to break it down. So 12x to the third, if I break it down into its prime factorization, I get 2 times 2 times 3, xxx. 30x squared is 2 times 3 times 5, xx. And 42x is 2 times 3 times 7 times x. Those are all broken down into their prime factorization. Remember those factor trees. If I look at what all of these have in common, this time it has to be in common to all three. Notice how they all have a 2, they all have a 3, and they all have at least one x. That's what I'm going to multiply together to get my greatest common factor. My greatest common factor is 6x. That's going to be my factor that I'm going to pull out of all three terms. My greatest common factor is going to be written in the very front of my expression. And I'm going to take what's left over in all three terms and write it down in a set of parentheses. So for instance, if I take out the 2, the 3, and the x out of 12x to the third, notice how I'm left with a 2, an x, and an x. If I multiply those together, what do I get? 2 times x gives me 2x squared. So I'm going to write what's left over first, since that was my first term. I'm going to do the same to my second term. There was a 5 and an x left over. And in the third term, there was only a positive 7 left over. I'm going to close that set of parentheses, and that ends up being my final answer. This is what we call factored. Notice how I pulled out front what they had in common and wrote what was left over in a set of parentheses. If I went back and did the distribution here, I would get exactly what I started with. 6x times 2x squared gives me 12x to the third power. 6x times 5x gives me 30x squared. And 6x times 7 gives me 42x. So you can actually check your answer by doing the distribution and making sure you get what you started with. So since we probably need some more examples, let's start on our second example right away. Here I again have three terms. I'm going to break those three terms down into their prime factorization so I can see what they have in common. When I write down what they have in common, notice how not all of them have 2's, not all of them have negative 1's, but they all have a 7. They all have at least one x. They all have at least 2 y's, but not all of them have z's, right? Remember, it has to be common to all three terms for me to be able to use it. So they had a 7, an x, and 2 y's in common. When I multiply those together, I get 7xy squared. This is my greatest common factor. That's what I'm going to pull out front when I do my reverse distribution. So I'm going to put that 7xy squared. I'm going to eliminate that from all three terms, and then I'm going to write down what they had left over. In the first term, we had a 5 and 2 y's to give me 5y squared. In the second term, negative 1 times 2, 3 x's and 1 z gives me negative 2x to the third z. And in the third term, I was left with 2 times 2 times 2, which gives me 8, 2 x's for x squared, 1 y, and 3 z's for z to the third power. I close my parentheses, and that is what I get when I do this factoring or reverse distribution. Remember, I can check my answer, right, by going ahead and doing the distribution and making sure I get what I started with. You will be able to eventually do this in your head, right? What does 35, 14, and 56 have in common, right? What's a number that will go into all three? How many x's do they have in common? How many y's and how many z's? You will eventually be able to do this super fast and do it in your head. Let's look at one more example. So this one only has two terms, right? So this time, instead of breaking them down, let's see if we can do this a little more simply. What number will go into both 4 and 18? Only 2 and 4 will go into 4. 4 won't go into 18, but 2 will. So to find its greatest common factor, I'm going to start with that 2 that'll go into both 4 and 18. How many x's do they have in common? 2 x's, right? So I can pull out 2 of those x's, or x squared. How many y's do they have in common? Since the first term only has one y, I can only pull out one y. That's my greatest common factor. They don't have anything else in common. So now in parentheses, I need to write down what's left over. If I divide this first term, 4x to the third y, if I divide that by 2, take out 2 of the x's and 1 y, what am I going to be left with? I'm only going to be left with a 2 and 1 x. How about the second term? If I divide 18 by 2, take away 2 of the x's and 1 of the y's, what am I going to be left with? 18 divided by 2 gives me 9. I don't have any x's left over, but I will have 4 y's. I put the wrong number right there. Let me fix that. And that's going to be my factored expression. Let me fix that again. There we go. We'll make it right. And that's factored. Now I would like you to try one on your own. I would like you to try factoring 6x squared y squared minus 14x to the third y using the greatest common factor. Pause the video so you can try this in your notebook and then resume the video when you're done. Did you get 2x squared y times 3y minus 7x? If so, you're done. You can go on. If not, please go back and watch one of the first examples again, and then come back and try this one more time. Remember to write down all of the examples and definitions from the videos. We will be having notebook checks, remember, and quizzes on the videos. Bring me any questions that you have, and I will see you next time we have class. Have a great day.